All right, class, now let's solve some logarithmic equations and applications. We did a ton of applications to exponential functions because they do have a ton of applications. Logarithmic functions, not so much. Okay, but, and so this section's going to go by super short or super fast. So, how do we solve a logarithmic equation? Obviously, a logarithmic equation, it's going to have some kind of log in it every single time, okay? All right, so same thing as we did with the exponential equations, we can just switch them from one form to the other. So we already know that if I switch this logarithmic expression to an exponential form as we practiced in 6.3, we keep the base, so the base of 2 to the power of 3 equals to x. Oh, well, that's 8, and that's the x, and that's the end of the story. Okay. So let's do this again. The base of 3, keep the base, to the power of 0 equals to 2x plus 1. Okay, no problem. 3 to the power of 0, that's 1. Minus the 1 from both sides, and then divide by 2. So 0 divided by 2, that's still a 0. And there's your answer. Oh, well, before I even get to switch from logarithmic form to exponential form, I need to get rid of this 2. No problem. I will divide both sides by 2. Again, we practice this quite a bit with the exponential equations as well. Okay, and now how do I switch this to exponential form? There is no base written here. Oh, wait a minute. If there is no base written there, it always means a base of 10, right? So that's a common log. It's the one where we decided to get lazy and not write the base anymore. So, but we know it's there, same as a square root, right? We know that 2 is there in the index of the radical, even though none is written. So 10 to the power of 2 equals to 3x minus 26. And so, of course, that's a number we know of. Keep solving here. Add the 26 over, and then divide by 3. So x is 42, and then it is. So again, be mindful that a common log is not going to have the base written there, but then we should know that means a base of 10. Same as a natural log does not have the base written there, but we all know that base is e. So before we get to this x, let's remove everything else that's happened. So minus the 3, divide by 2. And so now again, to get to x, you need to remember the base that we have written here that's not written is e. So therefore, e to the power of 2 equals x. So x is e squared. Now what is e squared? E squared is about 7.39. Okay, so again, e squared would be the exact answer. Whereas this is the approximate answer. Okay. All right, so again, as always, you're welcome to try some yourself. I'm first going to divide by 2. So 7 divided by 2 is 7/2 or 3.5. Now again, remember, the base there is an e. And to get to x, I will further divide by 6. So again, you can leave this as an exact answer, or you can give me the approximation coming out of the calculator. Oops. Divided by 6, we said. Okay, so 5.52. Okay. All right, well, now we're starting to get into a little bit more trickier problems, but first things first, kind of like, remember when we were like, oh, 2 to the x is 2 to the third? That means x must be 3. So, or what? Oh, square root of x is equal to the square root of 3. Oh, that means x must be 3. So the same thing here. Natural log of something equals natural log of something. Well, that means x squared must equal to 2x plus 3. Really, the reason why they went away is because we put a base of e under each of these logs, and a natural log and a natural exponential function cancel each other out, but you don't have to write that. So first time that we end up with a quadratic equation, right? So we already know how to solve quadratic equations. Here it is. We'll move all terms to one side. Then we're going to factor if we can. And the two answers here are 3 and -1. Now, be very careful. I'll go back here and be very careful, because it's happened quite a few times too, and even in this, and in the previous section when I was typing in negative numbers inside the log and the calculator would strike. So every time we solve a logarithmic equation, you must check your answer. As we did with square root equations, because not everything works with a square root and not everything works with a log. So you have to make sure that the numbers inside the log stay positive. Okay, and we didn't really check because I already checked for you. 8 is positive. When I plug in a 0, 2 times 0 plus 1 is positive. 3 times 42 minus 26 is positive. So all this was fine, but we need to make sure this works. And they actually both works, because 2 times -1 plus 3 is still positive. -1 squared, that's a positive 1, so that's okay. And of course 3 is going to be okay too. But be mindful of making sure that you get no negative numbers inside the log as you look back. Same thing, see how log with base 2 equals log with base 2? You actually put a base 2 under each of these logs, and that makes them go away. So the point is that the insides are going to equal each other. So I'm going to minus 2x from both sides, and I'm going to add 5 to both sides, and I end up with, I don't know why I squished myself, and I end up with x equals to 6, which totally works. Which totally works. 2 times 6 plus 1 is positive. 3 times 6 minus 5 is positive. All right. Now, what do we have here? Well, we have way more than just one log. You can't just drop the logs whenever you please. It's only if a log equals to a log, and not log plus log equals to log. So don't just drop the logs as it is. Okay, so, however, what we're going to do in all these problems is we're going to combine our multiple logs into one single log. And that's what we practiced in 6.4, I believe it was, when we talked about the properties of logs. So, as long as the bases are the same, you get to multiply, combine two logs by multiplying their insides. And now I only have one. And now I can go back to what we had before, where you take a logarithmic equation that equals to some number, right? And you switch it to the exponential form. So here we have it, 2 to the power of 3 is equal to whatever we have here, which is 2 times 3x minus 5. So this is now a very nice linear equation. Add the 10 over, and you end up with divide by 6, so you end up with x is 3, which 3 times 3 minus 5 stays positive. So far we didn't find a problem that has a problem. Okay. Same thing here, you have two logs that are added together, you can just drop them. But you're going to combine into one log by multiplying their insides. So now you have it. A log equals to a log. You basically put a base of e on both sides of the log, and that takes each of these individual logs away. So as you see, we end up again with a logarithmic, with an exponential equation. So two answers, right? I'm going to move all terms to one side of the equal, as we do with exponential, with quadratic equations every single time. And then I'm going to factor, and this time I have an x as the greatest common factor. And the two possible solutions are that either x is 0 or x is 7, right? X minus 7, 0 makes x equal to 7. And of these two numbers, the x equals to 0 does not work because you cannot have 0 inside the log. 12 times 0, by the way, is also 0. Put in ln of 0 in your calculator and it's going to say, nope, not in the domain. So don't do it. Okay. And 7 is positive. So again, you need positive numbers. Positive numbers. So not 0. 0 is not a positive number. Okay. So 7's going to work. All right, and here are a couple more. Same thing, we're going to combine the sum of these two logs into one log of multiply the insides. Then I'm going to switch from logarithmic to exponential form. And as you see, since this is a quadratic equation, I'm going to move all terms to one side of the equal and factor. And so numbers that multiply to 10 and subtract to be 3 are positive 5 and negative 2. And again, negative 5 is not going to work. Okay, can't put a log of negative 5, but can you have 2? Yes. Common log of 2 is positive, 2 plus 3 is positive, so that works. Oh, here's an interesting one, as we have a difference. And what does a difference between log turn into? It's going to turn into a quotient. Yes. Okay. So, again, change it to an exponential form. So 4 to the power of 2 equals to x plus 2 over x minus 4. So, good thing that we learned how to solve rational equations as well. So rational equations, equation with fractions, what we do is we want to get rid of the fractions next. So we'll multiply both sides by this least common denominator. So therefore, the x minus 4 is going to go away. It's going to get put over to the other side of the equal, therefore. So there I have 16x minus 64 equals to x plus 2. All right, so let's get the x's to one side, the constants to the other, and now divide both sides by 15. So I'm just going to take my, okay, here, what's 66 divided by 15? 4 2/5. And that's 4.4 in a decimal form. So yeah, 4.4 plus 2 is positive. 4.4 minus 4 is still positive. So that's an okay answer. Okay. And that's it. Here it is. This one's actually pretty easy. So applications for logarithmic equations or logarithmic functions are a few. Of course, your function can be logarithmic, and then we just need to solve for a piece of it. You'll have a few homework questions like that. But usually we describe functions that measure intensity of sound and intensity of earthquakes using logs. So the formula for measuring sound intensity in decibels, D, is defined by this equation right here, okay? Where I is the intensity of the sounds in watts per square meters, and I naught, we call this I zero, which is 10 to the negative 12, is the lowest level of sound that the average person can hear. How many decibels, so D, I have to find D, are emitted from a rock concert with a sound intensity, the sound intensity of 4.7 times 10 to the negative 1 watts per square meter. So all I have to do really is just to plug the number in. That's all. You don't have to solve for anything. Just plug in 4.7 times 10 to the negative 1 over, if you remember, I naught is always 10 to the negative 12. Okay. And you can take this and put it in your calculator exactly as you see it, or you can simplify a bit. And of course, I'm just going to simplify a bit. And the reason for it is because I do want to remind you of some rules of exponents. So remember, when you divide numbers with the same base, you subtract the exponent. So what is negative 1? Subtract negative 12, because that's what we're doing. We're taking the top exponent and we subtract the bottom exponent. And so remember how when you subtract negatives, you end up with a positive. So that's the same as 4.7 times 10 to the power of 11. And that's a much nicer thing to type in, just for that simple rule right there. I could even go on and show you more properties of logs, really. And again, you can type this in and have gotten an answer, but I just want to show you why we're using common logs for this. And so the properties of logs say, the properties of logs say that a log of a product can be split into the log of first plus the log of the second. And now if you remember, the common log which we're using here is a log with base 10, and log with base 10 of 10, they go away. So those cancel into an 11. So that's what you would have to only type in your calculator. But of course, all those properties of logs is really not a big deal. You could have even not switched the negative exponents either. So here it is. So I had a 10 times common log of 4.7 times 10 to the power of 11. So 116.7, about 117 decibels. That's a lot, by the way. All right. So here it is, easy. Your few homework questions you're going to have are just as easy, where you just plug the numbers in, find the intensity of an earthquake and intensity of a sound. So that should be quite straightforward. And again, the logarithmic equations, again, especially once you practice with the exponential equations over and over, hopefully these rules are starting to gel in a lot better. And you should be able to solve these problems with all the practice we've had.